Hi everybody, I'm Professor Rad, and today we're going to apply the distributive property to help us simplify certain types of expressions that involve fractions. So that's essentially what Note 7 says. We're going to look at one of the examples from the last video, and instead of using our order of operations to simplify, we're going to use the distributive property. This is especially helpful if each of the denominators of the fractions inside the parentheses, if each of those denominators is a factor of the number you're multiplying by. So the specific situation we're looking for is multiplication by a whole number, and each of those denominators goes into that number you're multiplying by. That's when this is most helpful. So the distributive property says if you have a number times some stuff in parentheses, and that stuff in parentheses is being added or subtracted, you can distribute that multiplication to each of the things inside. So I can write this as 24 times 17 over 6 plus 24 times 3 over 8. Now the technique that I'm going to use here is sort of an amended version of the prime factorization technique. And this is why it's helpful when the denominator is a factor of the number we're multiplying by. Before I do that, I'm just going to put the 24s over 1s so that everything is in fraction format. And now here's what I'm going to do. I'm going to say this denominator is a 6. How many times does 6 go into 24? Well, 6 goes into 24 4 times. So over here, I'm going to write 6 times 4. That's how I'm rewriting 24. So I'm using a strategic factorization, or I'm using a factorization instead of the prime factorization, because these numbers aren't prime. But I'm doing this because one of the numbers up here matches this denominator here. Okay, how about for this other one? My denominator is 8. How many times does 8 go into 24? Well, 8 goes into 24 3 times, so I'm going to rewrite 24 as 8 times 3, and then I'm going to leave this one alone. So the reason I'm picking this specific type of factorization instead of the prime factorization is because I can cancel straight away. It's less work than finding the full prime factorizations, and they'll just cancel straight out. Same thing with these 8s. We've got one on the top and one on the bottom. So now what I've got over here on the top is a 4 times a 17. So I'm going to do 17 times 4. Yeah, let's do the traditional method. We'll get a 68. And the only thing left in the bottom is this 1. And for the other fraction, we just have 3's in the numerator. 3 times 3 is 9. And all that's left in the bottom is 1. Now, notice that both of our fractions have a common denominator of 1, so we can just add across the top. That's going to give us 77 over 1. But any number over 1 is just itself. So we just get 77. So this is the same answer we got using our order of operations, but we got there with a little bit less pain than having to get a common denominator to add the fractions and so on. So if you notice this technique is very helpful. If, for example, this was a 5 instead of a 6, then it's probably going to end up being painful either way, unfortunately. Because 5 doesn't go into 24, so you wouldn't get this nice canceling going on. But if you do notice it happening, that distributive property can be really helpful. If you're heading into an algebra course after this one, this technique is also really helpful when you go to solve equations that involve fractions. You'll want to multiply both sides of an equation by a common denominator because of this sort of effect going on here. All right, so we have an example for you to try out on your own. In the next video, we will be using our calculators to get answers and talking about like implied answer formats. So sometimes a math teacher will use words to imply whether they want a decimal or fraction answer without saying decimal or fraction. So we'll talk about that sort of language, those clues that can be used, and using our calculator to solve. So I hope you have a wonderful day, and I'll see you next time. Bye.